Okay, item number 8.
Item 8, report on the findings of the potable reuse feasibility study.
Okay, Mr. Hagmark again.
Madam Mayor, Council, Joshua Hagmark, Water Resources Manager, here to talk about a summary of our potable reuse feasibility study, and this is all in advance of our discussion. We ultimately have to make a similar presentation to the regional board before June 30th. So we'll be going around back through the feasibility, the study background and objective, and step back a little bit. As you may recall, about a year ago, we were talking about the subsurface intake. This is the other component of that study. And so the study background and objectives, they were all very kind of tied together in the work plan that we did. We'll be going through the basis of design, conceptual design, the screening process, and the conclusion, and ultimately the summary. So as you may recall, on September 23rd, 2014, when we were really deep into the discussion of whether or not to reactivate the desal facility, staff was directed to evaluate the feasibility, cost, and timeline associated with both converting the offshore facility to a subsurface intake and look at the options about potable reuse. And basically, the scope includes identifying feasible alternatives. The scope did not include identifying the best alternative. We feel that's an objective best suited for the long-term water supply plan, which would then identify how much water we were looking for. So we held a discussion. Workshop number 1 was held on August 12th. We held workshop number 2, which was focused on the subsurface intake, on January 27th. And then most recently, the potable reuse workshop, which was held on October 26th. And we did not need to hold workshop number 4. And the work plans define how the studies are to be conducted. There were 7 sections to the work plan. The work plan was approved by the regional board on October 20th. Within the work product, there's an introduction and background, typically called TM, or Technical Memo 1, regulatory and permitting requirements, Technical Memo 2, and TM3, basis of design and initial screening analysis. TM1 provides the study goals and approach. Evaluate alternatives to desal using screened open ocean intake. That's what the objective was. First, evaluate technical feasibility, then evaluate the social, economic, and environmental feasibility of technically feasible alternatives. Information can inform future, can and will inform future. And I think the key is here is understanding the maximum yield that is technically feasible from these alternatives is what we were looking for. In Technical Memo 2, TM2 identified all the various permitting agencies that would be required, including the Army Corps, Coastal Commission, State Water Resources Control Board and its various arms, Santa Barbara County Public Health, and of course the city itself. TM3 is where it gets into the meat of the basis of design, and I think all of this information is in the summary is just basically baked into the feasibility study that we did. In the basis of design, we were looking at the maximum yield that is technically feasible, even if the yield is not sufficient to fully replace the desal screened open ocean intake or the desal plant production itself. That would be the potable reuse project. All of this information is available on this website here, and it's being hosted by NWRI. We have the video of the public meetings. We have the presentation on there, the PowerPoint, and then, of course, the study there. All of this information there, everyone, even all the public comments received with responses from the technical advisory panel to those public comments. I think this has been a very open and transparent process. I've been really appreciated how this able to flow, and I think it's actually a really good, potentially a model for us when we're talking about a long-term water supply plan and wanting to make it a very interactive process, open process. So the way that these alternatives were categorized, there were infeasible, NF, not potentially feasible, which is the PF with a little asterisk, and then potentially feasible. Only potentially feasible alternatives were evaluated for social, environmental, and economic feasibility. This process was approved by the regional board as part of the October 20th approval. So let's get into the potable reuse study. So we looked at 3 different types of water. Non-potable reuse, which is what we call now recycled water, indirect potable reuse, and direct potable reuse. And I apologize, but it just ends up being easier sometimes to talk about acronyms, and so we have NPR, IPR, and DPR. Feel free to stop me and ask questions at any time. Water quality and treatment needs, treated water production capacity, subsurface properties and hydrologic considerations, available project sites, project life, and reliability features. All of these were baked into the basis of design. The target production capacity as specified in the work plan was to replace the city's permitted desal plant capacity at 10,000 acre-feet a year. In order to do that, the city already produces 1,400 acre-feet a year of a non-potable water. So in essence, we are actually looking for 11,400 acre-feet of water to replace the desal intake. And so we'll start with El Estero flow characteristics. And as you can imagine, wastewater flows come in at different volumes during the day, which make it challenging to basically be able to, you have a lot of storage of treated wastewater flows throughout the day and throughout the season. So what we did is we took at the long-term average here, and we're able to come up with 7.73 million gallons a day, which equates to about 8,600 acre-feet a year. Again, as you may recall from our current wastewater flows, we're getting about 6 MGD into the plant, so far less than this average number. But I think for the sizing of the facility and wanting to maximize it, I was supportive of using this larger number because we want to make sure that we'd have that capacity within this treatment plant to do that. Non-potable reuse, currently practice, basically we take our secondary effluent and it's treated by microfiltration and then chlorinated. For the study, it is assumed that the non-potable reuse facility will be relocated because part of this we looked at trying to keep some portion of the non-potable reuse facility going with IPR and DPR. So space was a really big, was an important part. So one of the major components to any DPR, IPR is the advanced water treatment facility. We basically used the annex facility across from the El Estero wastewater treatment plant. It was about 2.5 acres, and we filled that site up, and I have a little picture here of what that looks like. It really is key to keep this facility in close proximity to El Estero. It's the piping. You're piping all this wastewater flows over there. You do have and will always have some type of waste brine disposal from the advanced water treatment plant. And, of course, it's an industrial operation, so we're best to put an industrial operation in an industrial zoned area. So just to kind of orient you, this is Highway 101 back here. This is the desal plant right here. El Estero, the labor line right here, Ananali. So this is Laguna Creek, or Laguna Channel, I'm sorry. And so what we have here is equalization tanks. So this takes the treated wastewater and allows us to kind of buffer it through the treatment process because we get, probably 8, 9, 10 MGD coming in the morning when people are using water in the morning, and then it kind of dies off, and then it picks up at night, and then it really dies off at night. And so we want to create a uniform flow going through the treatment plant, and so you need this equalization basins. And then, of course, you're going to have some type of storage for the treated water. It needs to sit in chlorine and ensure adequate disinfection. And then what you're seeing here, very similar to the recycled water, this is the microfiltration. So these are the nanotube technology that takes out all the particulates in the water. And then over here is the reverse osmosis, which are taking out all the salts and viruses and other stuff. So IPR, this is indirect potable reuse, which there are several forms of it. One being, and probably the most commonly known, is we're injecting basically treated wastewater back into the ground. And again, just walks you through the various processes here. What I wanted to point out with this is there is numerous processes to go here. This is an energy-intensive process. This isn't, I'm not trying to detract from this. I'm actually just setting the stage that as we continue to diversify our supplies, whether it's potable reuse, desal, they all require an extensively more energy than our surface water supplies have. And I'm not saying that's wrong or right. I think supports the council's desire to kind of develop more renewables, because these alternative water supplies and diversification supply is going to require additional energy.
Can you give a comparison with this versus the energy needed for desalination? Is it much less? Is it about the same? Do you have any?
It's pretty close. At this point, we just have estimates. It's somewhere in the 3,000 to 4,000 kilowatt hours per acre foot, and right now our maximum guarantee with desal is 4,400. And what you have to take into consideration here, particularly with when I get to DPR, is the pumping cost to pump it up to Laurel. Then you got to treat it again at Cater. So all those combined electrical costs. What you have here is the cost of probably a little less energy, but you still have the pressure of pumping it down into the groundwater basin that you have to overcome. So are there other challenges here? I just kind of wanted to set the stage. Again, we go through a lot of this stuff. I'm trying to give a presentation that really takes about an hour and a half, 2 hours and less, but all that information, and I think that's why I wanted to point to all that stuff on the website. It's all available if there's anybody who's interested in looking at all that stuff. It's all there. This, just for example, and just wanted to give you a flavor for it, we looked at the Foothill groundwater basin. Here's the Pacific Ocean down here. Here's downtown Santa Barbara. Here's the San Ynez Mountains. This is the Foothill Basin. This is Storage Unit 1. And what we were looking at here is how IPR might work with our groundwater basins. And what you see is the need to drill about 12 injection wells. As you may recall, a groundwater well costs about $2 million. So each one of these would be about $2 million. And then you got to find the property to drill those. But this would be the maximum number of groundwater wells we feel could be reasonably put in. And even our technical advisory panel had some questions about whether that was really realistic. And then with this, you have to start drilling more extraction wells, because in order to take advantage of that water, you'd have to be able to pull it all out of the ground, and our current well infrastructure is not sufficient to take advantage of that. So you'd have to drill more extraction wells. So all of this comes down to a question about where you site them, how could you site them, and of course there are several challenges with IPR. When you start injecting water on the ground, you got to be careful it doesn't come back out and cause other problems. Our full report goes into a lot of detail on this. So then we go to DPR. This is direct potable reuse. This is not a flange to flange. That's kind of the terminology. This is not putting direct potable reuse into our distribution system. The state board is not contemplating that right now. We're not contemplating that. Where we really took this is a raw water augmentation. The state board is seriously looking at that. They felt there is reasonable regulations that could actually support that. And so I don't want to get people alarmed that any time in the near future we're going to be going directly into our system. That's not what's being contemplated. So as part of the study, we laid out these various alternatives, and as just to kind of show you how it worked. So in this first alternative 1A, we looked to utilize some level of non-potable, so we'd still have some level of recycled water in the system that we would continue to try and utilize, but then we'd also then try to maximize the direct potable reuse. And then in 1B, it went all into direct potable reuse. The reason that you would look at this option here is when you go direct potable reuse, there is quite a bit of water lost to brine because you're taking it up to that higher level of treatment, versus indirect or this recycled water where we don't really have a brine waste that comes off of there, not to the extent that you'd have with direct potable reuse. But in this case, this was kind of a maximum, and the technical advisory panel just chimed in on this, that these are pretty lofty, dreamy numbers, but realistically, I think we're somewhere around 5,000 acre feet would be a realistic number. But just giving an order of magnitude about what we're talking about that could be repurposed from our treated effluent. And then there's various other alternatives that, combinations that we looked at as well. And this is just, again, I'm just going to pick one. This was 1A, where we're doing some portion of recycled water and then also direct potable reuse. And you can see in this case, nearly 8,000 acre feet going into direct potable reuse, losing about 1,500 acre feet to brine discharge as part of that process. Just gives you an idea of a water loss in there. And then here's the 1A, kind of how that would work. Right now, basically utilizing the recycled water system that goes all the way up to the golf course, extending that pipeline from the golf course up to Laurel, and being able to introduce that water into Laurel, where it can then be retreated at the Cater Water Treatment Plant and then distributed. So we'd have multiple layers of safety in that system. The treatment process itself has multiple redundancies. You'd have a storage buffer on site where the water would retain. It'd be sampled and tested. Then you'd have 5 miles of piping roughly that gone up to Laurel, where the water could continue to be tested and or intercepted if there was ever a problem. Then it gets introduced into a body of raw water, and then treated again as though it was a surface water supply. So you have these various layers of buffers that we might consider. So none of the potable reuse alternatives met the study goals. And 4 of the alternatives passed all initial screening criteria except for one, and that was the capacity limitation. We're basically limited on the amount of effluent coming out of El Estero. And then for IPR, alternatives did not meet additional study criteria. There was insufficient groundwater storage capacity. We really couldn't get more water into that basin, regardless of the available effluent. Several alternatives were discounted from further study prior to initial screening. The one that seems to be coming up is taking this potable reuse and injecting it into the seawater coming on shore. The challenge with that is you would still have a 50% loss of that water going through the desal plant. As you recall, that 50% of the water is rejected as it goes through those membranes, and so it doesn't change the recovery on those membranes, and so you really would be throwing away a lot of water even if you introduced it at the front of the plant. Seawater intrusion barrier, also not really an effective use. You'd be losing a lot of that water to back out to the ocean. And we're not talking about cheap water here. This after you've gone through this much treatment, this is pretty pricey water as well. And then surface water applications, unfortunately, this isn't Fresno, or I guess that's a good thing. We just don't have wide open spaces where you can store water and allow it to move into the ground, and our groundwater basins make it difficult. We don't have these nice easy connections to the groundwater basins, so it's very limited how much water you could get in, even if you had a space to put it. I will say that the technical advisory panel was pretty excited about our setup. They felt that when the regulations do come around, they felt that the way that our city has kind of been set up, we're a pretty ideal candidate for direct potable reuse, which was nice to hear them say. And they were eager to see us run forward and do some type of pilot with us. And I said, hey, I'm happy to do it with your money. Those are some folks on that. We were talking about the city of San Diego. These are the folks that really have an R&D budget that they can afford to do a lot of pilots and really push the limits on this stuff. And unfortunately, I don't think we're in that position. We really need to see what the big boys, Metropolitan, Orange County, San Diego really come up with, and then I think we'd be quick to kind of see how that would work here. So the State Water Resource Control Board is pushing forward with developing DPR guidelines. The Division of Drinking Water concluded in late 2016 that it is feasible to develop these regulations for DPR. And we've kind of teamed up with 3 other water agencies to put forth plans for how we would DPR, because what the state's kind of looking for is, okay, if there's interest, how would you do it? Because we're creating regulations and it'd be nice to see what you're thinking. And so we've kind of did a lot of that work in this study, which is perfect. So we're planning to work together to present these findings to the state board to help them with developing regulations, so when they come out, they could specifically speak to our situation. And the project will be facilitated by NWRI and the Water, Environment, and Research Reuse Foundation. So in summary, the information in the study will be used in the next long-term water supply update. The update will reflect the new drought of record, the pending Kachuma environmental decisions, pending reassessment of the Kachuma operational yield, and of course the new normal for water use and conservation in our community. Both the subsurface intakes and potable reuse alternatives, along with other potential options to be evaluated as part of that whole update. And
when the meeting is in April?
May
right?
11th and 12th.
May 11th.
It'll be held in San Luis. We're hoping we would be able to do it here in Santa Barbara, but for whatever reason, they weren't able to accommodate us here.
Okay, not that far away though. Okay, we have Kara Redmond has a public comment. Speaker slip up, come on up. Good afternoon.
Good afternoon, Mayor, council members. Kara Redmond, Santa Barbara Channel Keeper. Although times are changing, history does in fact repeat itself. Similar to when the city first constructed its desal plant at the end of the last drought, we've had a ton of rain these past few months, which has brought Kachuma up quite a bit, restored flows to our rivers, and ensured the availability of plentiful water from the State Water Project. I'd imagine that the renewed availability of these cheaper sources of water supply is going to make it somewhat difficult to justify the extremely high cost of operating the desal plant at the production capacity previously contemplated. It also makes the findings of the potable reuse and subsurface intake feasibility studies even more relevant and valuable. Unfortunately, to our chagrin, the city designed both of these studies to ensure the findings that these environmentally superior alternatives were not feasible by defining feasible as capable of producing 10,000 acre-feet per year of water. This was done despite the fact that the city is recommissioning the desal plant to produce less than 1/3 that amount of water, and despite the knowledge that the city doesn't generate enough wastewater effluent to produce 10,000 acre-feet of recycled potable water. Those who've taken the time to review the feasibility studies come away with the opposite answer, that both subsurface intakes and potable reuse are in fact feasible and capable of producing at least twice as much water as the 3125 acre-feet per year the city intends to produce with desal using environmentally harmful open ocean intake. Now that the drought emergency has abated and there's no need to make desperate decisions in panic mode, we hope you will go back and give subsurface intakes and potable reuse a much harder and fairer look. Given the extremely high cost and insignificant environmental impacts of desal, it makes sense to pursue alternatives. Potable reuse in particular makes a whole lot of sense and is, in the opinion of many, the wave of the future. Recycling wastewater for potable and non-potable reuse is a highly reliable, local, drought-proof source of water supply that also reduces the environmental and public health impacts associated with discharging treated sewage into the ocean. This is the direction that Santa Barbara should be going, like Orange County, LA, San Diego, and other water districts. And Channel Keeper is here to help with the outreach to turn around and raise public awareness, turn around the toilet-to-tap yuck factor into a yay. We're glad the city is participating in the DPR coalition, and now that the drought is dissipating, we hope the city will take steps to pursue potable reuse to diversify and enhance the sustainability of its water supply portfolio. Thank you.
Okay, that concludes public comment. It's to the council. Mr. Hart.
Well, I appreciate Ms. Redmond's comments. I share those views and look forward to continuing to evaluate this. I spent a fair amount of time digging into this website and really looking at the reports. And there's a lot of very valuable technical information there, but it's very hard to access and digest. And so I would just ask staff to think about the possibility of having an executive summary that kind of pulls together this technical information, because one of the fundamental disconnects, I think, is between what this study was intending to do and what it was trying to evaluate versus, the finished version of the long process Ms. Redmond's talking about that's going to happen in the long-term water supply planning process. We didn't have time to do everything at once in the drought crisis, and I think we've always intended to have this evolve over time as information becomes more available and the supply situation becomes more stable. But having a simpler, more civilian, accessible executive summary of this work would really be helpful. I'd found it challenging to follow this, going through the different technical memos and trying to pull it all together. And your report even was challenging following along. So I don't know if it's something you have to do right away, but I think to make this information more relevant for the community and to advance the conversation, it'd be helpful to have that in this report.
Anyone else? Mr. White?
Thank you, Madam Mayor. And I think one key element here is the time that it's going to require to go to direct potable reuse. And what I've heard in the discussions over these months has been quite a number of years before all the different pieces, that is to say regulatory as well as technical pieces, come together. Do you have a ballpark feel for what it's going to take in terms of time for those different steps to unfold, Mr. Hagmar?
Madam Mayor, Councilmember White, thank you for asking. We did meet with our local Department of Drinking Water to basically ask them. I mean, this is a group that's probably the most cautious about this thing moving forward. And they feel like this has got some momentum behind it. And they believe that based on the work that the city of San Diego is doing, that they're likely to see regulations in the next 5 to 7 years, which seems like they're moving. If they can keep that pace, that would be a pretty good pace for I think something as significant as this. I mean, the key here is we can't afford to have a mistake. It will set it back for decades if it does, and they want to make sure when they develop the regulations, they take into considerations contaminants of emerging concern, how drugs will be removed from the water. And so rightfully so, they want to get it right. And but I do believe there's a certain momentum that this drought has put behind it. And I think that we will see something in the next 5 to 7 years. Even what's interesting, I got an email yesterday asking to lend some support behind a state bill to actually put some dates. And so we will be actually forwarding that on to you, Ms. Mayor, for you to lend our support behind that, but to put some dates to developing these regulations. And one of the things that was interesting to note is they're actually moving away from, after all this work, they're moving away from the IPR, DPR designation, which I think is helpful because too many times when people hear direct potable reuse, I think it's going straight into the system, straight to people's taps. And obviously, I understand why people would have even higher concerns. But so what we're talking about is something that is different than that. And so relabeling all of this as potable reuse, and then what we're talking about is raw water augmentation, is in particular what our form would be called, but we're actually looking to put it into a surface water. So I think changing the terminology is important because we do, and I appreciate Kira's support, we do want to build a positive public support for this. Because it certainly, we want to go into this eyes wide open and people feeling comfortable about their water. We certainly don't want to lose the trust of the community here.
Thank you. This does not require a motion of any kind, so we got the presentation. Any other comments? I don't think so. Thank you very much, and we hope things go well in May. Item 9.